Hello dear friends, welcome to Eazi Lessons. In this session, we will be discussing about arrays. So what is an array? In some situations, we have to store a lot of same type of data. For example, suppose we want to find the total number of total marks of a student, and the student is having 10 different subjects. So we have to declare 10 different variables to store the marks. Or suppose we want to find the average marks of different students in a class, and if the strength of the class is suppose it is 45, so we have to declare 45 different variables for storing the average marks of 45 different students. So in such cases, the number of variables increases inside the program, and also the length of the scanf statement gets increases. That means we have to write scanf %d, 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 etc. So in order to reduce the length of the programming statements, or in order to make the programming more easier, the concept of array was introduced. So array can be defined as a derived data type, and it is used as a collection of same type of or homogeneous elements which are stored under a single name in continuous locations. That means if you are using an array, we can only store a collection of same type of elements. That means if you are storing integers in the array, you can only store integers in it. So it is a group of integers, or it is a group of float numbers, or it may be a group of characters. Homogeneous or same type of elements are stored inside the array. And what is the peculiarity of array? These whole elements are given a common name. Suppose we are storing the average marks of n different students. The whole n average marks are given a common name average. Okay, so this array will be having a collection of elements, and all these elements will be having a same name. And also, if you are using individual variables, it will be scattered in different locations in primary memory, isn't it? The allocation will be done according to the free space available in the main memory. But when we are using array, whatever the size of the array, that particular size, that particular array will be stored as a contiguous block. So that is a peculiarity of array. It is a collection of same type of elements. It is stored under a single name, and it is stored in a continuous location. And in the array, we have already told that we can store both integers, characters, or floats. Whatever data can be stored. And there are different types of arrays: single dimensional array, double dimensional arrays, and multi-dimensional arrays. So we told that the whole elements, whole homogeneous elements or whole collection of elements will be stored under a single name. So how it can be, each element can be referred. For example, if there are 50 students in a class and that particular class is class 10, suppose class 10. So how will you identify each and every student of the class? By their register number, isn't it? You can call the student by specifying the register number 10 of class 10, register number 11 of class 10. In similar way, in each and every element of an array will be having an index number. This index number, sorry, spelling, there is a small spelling mistake, the index number. This index number can be either known as subscript number. Okay, so let us correct the spelling. So the index number or subscript number is a number which we are using to refer the student in an, or refer the element in an array. And we have already told that these array elements will be stored in a continuous location. So when the base address is obtained, suppose 1000 is a base address or the address of the first element of the array, we can automatically calculate the second element's address, because if it is an integer array, suppose consider the first case, in that particular array we have stored only integer data, and for integer data we know that 2 bytes are required. So if the starting address of the array is 1000, we can easily say that the second element will be at 1002 and the third element will be at 1004 and so on. Okay, so we can store both integer numbers and float numbers in a single dimensional numerical array. So first of all, we are considering single dimensional numerical arrays. And the starting address of the array is known as a base address. And we can see that the whole array is stored under a common name average. And in this example, it is stored under a common name register number. And each and every element is accessed using index number or subscript number. In C language, this index number always starts from 0. So for making an array, for implementing an array, we have to declare the array first of all. So how we can do this array declaration? The syntax is data type, array name, size. So if you want to store an integer array, or if you want to store n integer elements in an array, you can declare as, you have to specify the data type as int, and then you can give array a particular name. Any user defined name can be given for array. So here I am giving the name A, and you have to specify the size. Size means how much elements you want to store in that particular array. So in this example, I have given as int a of 10. That means a is an integer array in which 10 elements are going to be stored. So while this declaration is given, memory allocation will be done in the background. So as it is an integer array, each element requires 2 bytes. So for 10 elements, 20 bytes will be allocated as a continuous block, and it will be given a common name A. And if it is a float array, float A of 10, we know that for each float element, 4 bytes are required. And so 40 bytes will be allocated under a single block, and it will be given a common name A. Okay. And then comes array initialization. We have seen in C program, an initial value can be given to any data, any variable during the declaration itself. That means we used to give int x equal to 10, int y equal to 10, etc. In the same way, initialization can be done for array elements also during the time of declaration. Consider this example, int a of 5 equal to, so we have declared an array of 5 size, and I have given the initial value during the time of declaration itself. This is known as static initialization. From the term static, it means that this initialization will be done during the compilation time itself. So while the array is created, an initial value will be set to the 5 positions. In most of the situations, we used to give the values to an array elements during runtime by asking the user. So next comes the runtime initialization. During runtime, the value can be read using scanf statement. Scanf %d, %d you can give ampersand a of 0. That means address of the value will be gone to the address of 0th element of the A. Next value will be going to ampersand a of 1. In this case, you can give the array elements. But here there is a problem. While if the array is a large array, you have to give scanf percentage, d percentage, d percentage, a likewise. We have implemented the array in order to reduce the length of the scanf statement. So here also the length is not reduced. So there is another way, another alternate way for reading elements that we will be seeing in future. So here just understand that an array element can be read as, that means I just want to say that each and every element of an array is referenced as a of 0, a of 1, a of 2, etc. And also if you want to initialize a particular element only, you can give a of 0 equal to 10, a of 1 equal to 90. Likewise, initializations can be done. So here we are avoiding the length of the problem of length of the scanf statement. Here I am using a for loop to read an array because while reading we have already seen in the previous slide that the scanf statement, when scanf statement is used, the only difference is in the index number. That means percentage d, percentage d, percentage d, ampersand a of 0, ampersand a of 1, ampersand a of 2. The change is only being made onto the index number. So in order to make the scanf statement more beautiful, you can use a for loop. So here I have written a for loop like for I equal to 0, I less than 5, I plus plus. So the array contains 5 elements. In this example, 5 elements. Array has a size of 5 elements and I am going to read 5 elements to it. As the index number starts from 0, I have written the condition as I less than 5. That means in an array, as the index starts from 0, the last element, the last index of the array element will be n minus 1. That means if the array contains 5 elements, the index of the last element will be 4. So the loop should be executed 4 up to 4 from 0. So that's why the for loop is given as for I equal to 0, I less than 5, I plus plus. So in the first case, I equal to 0, 0 less than 5, condition is true. So the value will be read as scanf percentage d ampersand a of 0. So the first value will be stored in 0th position. Again, I gets incremented to 1. Again, condition is evaluated and as the condition is true, the value to a1 is read. The next case, I is again incremented to 2. 2 less than 5, condition is true. So the value to second index number is read. Again, I gets incremented to 3 and 3 is less than 5. So value to A3 is read using for loop statement. Again, I is getting incremented to 4 and 4 is less than 5. Condition is true. So in the last case, fourth element is being read. And what happens to I? I gets incremented to 5 and 5 is less than 5 and the condition is false. The loop get exit. Okay. In this way, an array can be read. Different operations on an array that can be performed are insertion, deletion, searching, sorting, merging, and concatenation. And also there is also one more process, that is traversal also. Traversal. What is traversal? Traversal is a process of visiting each and every element. Visiting each and every element of an array. That means without repetition, we are visiting each and every element of an array. Okay, so the first operation is traversal. The second operation is insertion. What is insertion? Suppose we have already an array and we want to store or we want to add some more elements into the array. That process is known as insertion. The process of adding a new element into an array containing n elements is known as insertion. Next process is deletion, that is process of removing unwanted items from array. So process of removing an element from an array containing n elements is known as deletion. And searching is the process of checking whether a particular element is present or not. And then comes sorting. Sorting means arranging the elements either ascendingly or descendingly. And next operation is merging. Merging is joining two sorted elements. Suppose there are two divisions for class 10. 10A and 10B. And the class teacher of 10A has sorted the mark list and find the rank 1 from there. And in the similar way, class teacher of 10B also has sorted the list and find the rank from class B, 10B. And the school is deciding to give a provisional proficiency prize to a student who has scored the highest mark from both these two classes. In that situation, we have to merge the two mark list of two classes into a single mark list, which is again sorted. In such situations, we can use merging. Merging is a process of joining two sorted elements, sorted arrays, into a third sorted array. And finally comes concatenation. Concatenation is the process of joining, simply connecting two arrays. Joining a second array to the end of the first array. So in the coming sessions, we will be discussing the operations in detail with algorithms and programs. Hope you understood this video. Please like it, share and subscribe it. Thank you.